All right, welcome everybody to another episode of this is Labs Talk.
This is Labs Talk.
This is Labs
Exactly.
Talk. And Heiko, don't worry, you're gonna be part of the show in a second, okay? But we typically start the two of us, right? And we actually try to recap what we've done before, and I don't remember what we've done before.
It's been a long time.
Yeah, it's been a long time
for all our audience. It's the end of the summer break.
Yeah. I think the thing that we've done the last time, we ended our quantum series actually, right?
Yeah,
we had like a 5 or 6 part quantum series.
We spoke a lot about quantum. I do remember we spoke to Isabel about the theory of all of it. We spoke to Anselme about post-quantum.
Don't ask me what
quantum safe
don't
crypto.
Ask me,
I don't remember all of them. We talked to Nadim about the problem that quantum possibly solves sometime. We spoke to... We're well prepared, everybody figures.
Yeah. But you know, I have the solution to all of this. I mean, the whole series, of course, is on YouTube, right? And the easy way to get there is labstalk.dev, which then just redirects to the YouTube channel in this case. And if you're interested in quantum, then you can take a look at that. But today we're switching topics now, right? So we're switching.
We talk about summer for a minute?
Yeah, for a minute maybe.
Just a quick minute. Because we've been out for so many weeks, no new episode for I think like 6 weeks, 8 weeks even. What have you done in the summer break?
Where should I start?
So many things.
Yeah. Many of these things have been over the weekends and cycling and running events, basically. But then with my family, I've been to the Elsass, which is very close by, actually. But what did I do? I also was running.
More running, more sports.
Yeah, more running, but also very good food, of course. Yeah, and some city sightseeing. And you've been to an incredible conference, I believe.
I have been indeed. I've been to the Y 2025 in the Netherlands. I spent 8 days there. And we were so lucky. It was such an awesome event. I totally recommend. I can put a link in the...
Is this a typical IT conference, or is it something different?
No, it's on a camping ground, basically. It's a camping event. It's much more a festival than it is a conference.
It's also an unconference, I believe, right? So it's all self-made by...
It's not an unconference in a traditional sense. Okay. There was a call for papers. Yeah. There was a proper schedule, so people had to go through a committee and be chosen with their talks. But on the side, there has been self-organized tracks and everything.
Yeah, cool. And how do you get more information about that? You just search for Y 2025?
Or you can listen to our sister podcast, actually.
Oh, yeah, exactly, to SaunaCast.
There is an episode on SaunaCast.
.xyz.
But enough of that.
Side. Anyway, I think we're going to switch topics now because I see Heiko getting a bit nervous already. So we of course are riding the vibe coding wave, right? And we only do agentic stuff, and we code MCPs every single day and A2A. And today we're going to explain to you what this is all about, right?
Yep.
And that's why we have Heiko from Google, and we should bring him on, right?
Welcome, Heiko.
Hello, Heiko.
Hey, welcome. Thanks for having me.
So Heiko, before we maybe start with who you are and what you do at Google, actually, how did you actually pass the summer so far? Actually, what are you looking for, maybe?
So I spent my summer here in London. I did not take any vacation, but we did have a pretty amazing conference here in London as well. 2 actually. One was called South by Southwest, which is usually in Austin in the US, but the first time they came to Europe this year, and that was in London. And then just recently, I was at the MCP conference here in London as well, which was all about MCP, Model Context Protocol.
For what we are planning to talk about, right? Like
right.
We figured already that's a huge thing. Now there's conferences. You go to these conferences. Heiko, tell us a little bit, why is it so important?
Before we go there, actually, could you tell us who you are and what you do for Google? I think that would be a nice intro.
That's a good
absolutely. So my title is called GenAI Blackbelt, and that does not mean anything to anyone. So basically, you can think of it as a solutions architect, really. So I work with external customers who want to build generative AI solutions on Google Cloud. And my job is basically to make them successful on our platform. And that could mean many different things: blueprinting architectures with them, building a demo for them to show them what is possible on our platform, having enablement sessions to make sure the developers from the customer know how to use our AI models, basically anything and everything that is needed to make them successful.
Yeah. Sounds very cool, actually. And it's much needed these days, I guess. So now, okay, then let's start, right? So we're living in this world of agentic AI, right? So and that's why we're talking about MCP.
Maybe not everybody who's listened to Labs Talk is that far ahead already. We spoke a lot about AI, and everybody probably heard about agents. But before we dive into any of that, Heiko, what is an agent to start with? What is an agent beyond that LLM and that chatbot craze that's on for the past 2 or 3 years? And why is it so important recently?
Yeah, that's almost the hardest question you can ask right away, right? What is an agent? You ask 10 people and you get you ask 10 people and you get 12 different opinions of what is an agent. So the way I describe it is an agent is an entity, and agents even existed before LLM, so I don't want to even say it's an LLM driven entity that can make decisions autonomously and on your behalf. Nowadays, when we talk about agents, most of the time we talk about LLM agents, but not necessarily is an agent driven by an LLM. It can just also be, a traditional reinforcement learning agent. So if you think back of AlphaZero or AlphaGo, that was an agent, right? Via reinforcement learning, it learned the rules of the game and then played the world champion in Go and defeated him. So to bring it back to now what we're talking about today, usually it is an LLM-driven agent with tools, with context, with memory that can act on your behalf, do things on your behalf, basically.
And can you maybe outline the journey that we've seen over the last 2 years, roughly, right? Since we kind of have these LLM agents, how were they built just a few months back, basically, and how and where does basically MCP, Model Context Protocol, get in now, basically? So what's the development journey here?
Yeah, that is actually a fascinating journey. So when LLMs became popular, which happened when ChatGPT came out, LLMs were a thing before that, but they really became popular when ChatGPT came out. Organizations started to build with these LLMs, but it was one request. You send one request to the LLM, and the LLM would only have its internal knowledge, and it sends it back a response. So you could ask it things that would be in its training corpus, something like, when was Isaac Newton born, or something like that. But very quickly, organizations and developers realized that that is good, but in order to really make it more useful, we should give these LLM tools in order to access real-world information, real-time information. So, for example, I can't just ask an LLM what is the weather today in London, because that was not in its training data set. I can also not ask it what is SAP's HR policy on vacation days, because it was not trained on that, because that's proprietary information. So the idea was, okay, let's give them tools, basically access to additional information. And the idea is that you pull in that additional information and let the LLM be the natural language interface. So if I wanted now to query about SAP's HR policies around vacation days, I could, sift through many, many different documents, or I could just ask an LLM to do that for me and give me back the concise answer for that.
Okay.
So that was the concept then when tools came into the into the picture. Now, the problem with these tools is that each large language model provider has a slightly different signature in terms of how they want to access these tools. So if you use something from OpenAI, that will have a slightly different signature than if you use something like Gemini or something from Anthropic. So what you would have to do now as a tool provider, as someone who wants to provide information to these LLMs in order for them to be more useful, I would have to develop 3 different interfaces, one for Anthropic, one for Google, one for OpenAI, in order to provide my tool to them. And that's exactly where Anthropic's Model Context Protocol, MCP, comes in. It is basically, I'm simplifying here, but I think for the purpose of this conversation, it's a good simplification. It's a thin wrapper around your tool, around your API, to make it be able to be read by any LLM. You, as a tool provider now, if you wrap it into an MCP server, you don't care anymore if the LLM that is calling you is from OpenAI, from Anthropic, from Google.
Okay.
It just works.
So it really
Does that make sense?
standardizes all the tool calls, right? And it also
right.
makes them available to the agents. Cool.
Only to take that a little bit further and also tie back to the title we gave this episode, or you explained to us how these LLMs can use tools and how these LLMs get some authority over certain things and to use those tools. But we're trying to go to agent type of communication, like when a LLM uses a tool, that's one thing, but now that makes an agent. At what point do those agents need to talk to each other? Why does that play a role?
Yeah, and that was actually exactly the topic of my talk at the MCP conference. Is when do I wrap a functionality into a tool versus when do I wrap it into an agent? And if I wrap it into a tool, we already know what we should be using in order to connect the agent to the tool. That would be the MCP, the Model Context Protocol. But if I need to wrap it into an agent, my functionality that I want to provide to the outside world, how then, does the requesting agent connect with the remote agent? And that's where the agent to agent protocol comes in. So the agent to agent protocol and the MCP protocol, they are complementary. It just now depends on how stateful or stateless the functionality is that you want to provide to the outside world. If it is stateless, if it is just I just need to send one request, what's the weather in London, and need to get one response, I can wrap that into a tool, right? Because I don't need the API to remember that I called it a second ago about the weather in London, because the next query might be about weather in Paris or something like that. But if the functionality that I want to provide is more stateful, then I might to actually provide this functionality in an agent that has a memory. And in order to then provide that functionality to the outside world, that's when we need agent to agent protocol. Hope that makes sense.
It does, to some extent.
Yeah, so to some extent. So would you say that basically having this memory is the decisive factor basically to go into agents, right? But then but this does not necessarily mean A2A at this point, right? I mean, because every agent has to some degree memory because it an agent is able to freely call some tools and stuff like that, and it preserves the memory during this time, at least in memory, I would say, right?
Yeah, that's right. So statefulness versus stateless is one question you need to ask yourself, whether you want to provide your functionality as an agent or as a tool. Other questions you need to ask yourselves is determinism versus ambiguity. MCP tools, again, are just wrapped API calls. And the way you call an API is you provide the API. The API tells the user its capabilities and what it needs via a structured schema, right? If I have an API that calls the weather, I need the location, and maybe I need, Fahrenheit versus Celsius. That's a structured schema.
Yeah.
If however, if I want to provide a functionality that requires more ambiguity, something like look for the cheapest flights from London to Paris, if that is a functionality that I want to provide to you, the way I would want you to call my function is not via a structured schema, it is more like a natural language query. And if that is the case, again, you would want to implement the functionality as an agent versus a tool.
Yeah, that makes sense. And this immediately brings up this association of our latest SaunaCast episode. Actually, I'm sorry to create that plug again, but we had this example. I'm not sure if you heard of it, but there's this gibber mode. And there's a YouTube video out there of like two agents talking to each other. For me, it was also, I remembered there was once a Google I/O conference where there was this.
Like the underlying example of an agent is that one that Google demoed as Google Duplex a couple of years back,
yeah,
where an agent from a Google Pixel phone calls I think a barbershop to create an appointment for a haircut, and it calls that a saloon.
Yeah.
Like, hey, here is Google Duplex. I want to make an appointment, and it has this conversation and all that. And the saloon responds, yeah, we have a couple of options and all that. That's basically the case. There is two people or two agents talking to each other. Yeah. And now this gibberling, and it's an obvious joke, and we can share that afterwards.
I'm not sure. Maybe it, at some point it's no longer a joke. But anyway,
but let me continue that just to round that. We started that. Let me round it off.
Explain.
Now, during that conversation in that video, that one agent says, "It looks like you're an agent." And now that we're both agents, does it make sense to switch to agent communication? And they do, and it sounds like modem sounds. And
I think they called it gibber mode or something like that, which is basically Morse code or like some non-textual or non-human understandable mode of communication, which
that's interesting.
I cannot completely deny that this would make sense at some point, probably, right? So I mean, if machines are talking to machines, then why should they talk more or less human language?
One reason I can tell you, so agent to agent protocol, the protocol as it is implemented right now would not allow for that. It would require the agents to speak in natural language. And one reason this is really important for organizations is for traceability and auditability. Auditability.
Yeah.
So if someone wants to, someone wants to be like, why, if you're banned, why did you make this decision? Well, I don't know. My agents talk to each other, and this is what came out. That would not fly.
Yeah, I mean, although of course I mean, sorry, I don't want to spin this too far, of course, but we could imagine there is some kind of super optimized language that can be actually translated back into some kind of human language, and then the agents could still speak that language, and we can still observe it, we can still trace it, but that's not
like only to get back to our main topic, maybe only to round that off. and before we go back into MCPs, or are there any industry approaches worth mentioning, only to close that loop? And now that we spoke about what exists and why it exists, only to get an overview what else is out there and whether there's other approaches.
Yeah. I would say right now, agent-to-agent protocol is a little bit forward-looking. There are not many organizations right now who are leveraging the agent-to-agent protocol. It's only the really most advanced ones. Most of the organizations and customers I work with still, are in the world of like, let's build one agent with maybe 3 tools, and let's not get ahead of ourselves and building like 10 agents that need to talk to each other. So I would say the vast majority of organizations is still very much single agent, maybe a few tools. But going forward, I see no reason why it should not be the case that let's take SAP again as an example. The HR department builds an agent, maybe internally first for themselves in order to, again, query HR policies or something like that. And then at some point, the engineering department says like, the HR agent that you have built there for yourselves, that would be really useful for our team as well, for whatever reason. Could you provide the functionality of your agent to our team as well? And that's really where then A2A would come into play.
Before we close the MCP topic, actually, I would have one more question on the MCP topic, because I mean, I played myself a lot with MCP, with all kind of lovely notebooks and fast MCP and these kind of things, and it's relatively quick to get started, right? But I noticed that a lot of these MCP servers, they run on my local machine, right? So I basically installed our desktop, for example, then I have 5 local MCP servers that connect to my file system. The other thing connects to my Strava account, and in the end, I can ask it, hey, create an overview of my recent Strava sports activities and write it to a file, for example, like that, right? So super cool. But isn't this is all no normal user will basically install these MCP servers. So I'm basically waiting for all these MCP servers to become the new API of Strava, for example, right? Of other systems out there, of some SAP systems, for example. Do you see this happening? Is this something that just takes a certain amount of time, or are we fine with local servers actually, and that's just the way to go?
No, I don't think so. I think local servers are very nice for local development, for experimenting, for getting familiar with it. But if you really want to provide a functionality to external customers, then remote MCP servers is usually the way to go. And I would actually not be surprised if Strava already has, some external remote MCP servers built already. I think it's exactly as you say, it's going to take some time and some rethinking, but all the companies, all the organizations that are currently offering some sort of functionality via an API, I believe will but additionally wrap this functionality into an MCP server, unless they have, really good reason that they don't want specifically LLM agents to consume that functionality. But if you want to provide that functionality, the web as it is right now will partially, shift towards an entity, a network where not only humans will query information, but agents as well.
Yeah. And I mean, one other development I see here is that it is relatively simple to write a prompt about, let's say, your Strava performance. I'm sorry, I'm in the sports world now, so we can try to map to some sales-oriented Sales Cloud topic. So maybe analyze my recent customer engagements and create a beautiful report out of it or so. And it would actually, at some point, it could very easily very quickly result in a lot of tool calls, actually, right? That probably result in a lot of API traffic. And I'm just wondering, what will happen? Because it could mean that we see, for example, new pricing or new strategies, actually, right? Because somehow this needs to be monetized, right? And it's very easy to make all these tool calls, but right now these APIs are primarily free, right? And if I access them with a local MCP server, they're still free. But I'm not sure. So do you think this will happen at some point, that we basically have we have an API that might be free, for example, and then an MCP endpoint which costs premium extra on top, basically, or how does?
Yeah, that's a super interesting question, and I'm afraid I probably don't have a very good answer for that, other than that there probably needs to be some rethinking in pricing structure. So there's Nilay Patel from The Verge. I don't know if you guys are familiar with The Verge or Nilay Patel, but he calls it the sandwich question, basically. So in the US, they have this equivalent to Deliveroo. I think it's called DoorDash. And DoorDash obviously makes money if you order a sandwich by taking a commission of your of the price that the end consumer is paying. But that's not the only way they make money. They show ads on the DoorDash application, on the app, on the phone. They try to upsell you to like DoorDash Premium and stuff like that. And now suddenly, if an agent orders the sandwich on your behalf, there's no need for you to go onto the app anymore. And therefore, DoorDash will lose a significant amount of revenue. And that means there needs to probably be some rethinking of pricing. I don't know exactly who's going to pay, who's going to fill that gap, but someone has probably.
I think it's really super interesting, right? Because I'm sorry.
No.
The agent really kind of becomes. I mean, I think I heard that months ago already, right? The agent basically becomes the new UI, right? And that's just like you described it. There's no need to go to the website, which shows you some ads, for example. But now the agent just kind of creates that order, and the agent doesn't care if you.
Exactly.
I'm wondering if you could add. You must have been thinking about this at Google, probably, right? To add some kind of an ad proxy for MCP. So, I don't know.
Or maybe if you use your agent, every 10 orders, it needs to contractually try to upsell you, or I don't know. I think it's super exciting. It's like the beginning of the internet again, where we have to figure out monetization strategies.
Whenever there's an agent who places an order, there's mandatory dessert with the order.
Yeah, or every 10 cool calls, there's a humanness check, basically, and you to verify that you actually watched the ad or something like that. That would be so bad, actually. Okay. Then I would maybe pay for premium finally.
just to be safe, nobody spits in your burger.
All right. I think so we discussed MCP, right? So we have you also got, thank you so much for the intro to A2A. What we also have in our pre-chat, what we took down here is talking a bit about Google ADK, which I understand is Google's agent development kit. So can you maybe give us a quick intro to what it is, and maybe also how it compares to some other development kits?
Yeah. So first of all, what it is it's an SDK in order for you to build very easily LLM-driven agents. Ideally with Gemini, but you are not limited to Gemini. You can build your agents with any LLM. And the idea is really, if you wanted to build your agent framework from scratch, you could, but it is very painful. Just like, building an SDK from scratch would be very painful, because these agents, as we discussed earlier, they need to have context, they need to have memory, they need to have a runtime, they need to be able to communicate with each other. You can build all that from scratch, and it would be very, very painful. So at Google, we thought it would be a good idea to make that easier for our customers. And in
And
terms of how it compares with, something like LangGraph or Crew AI, so it's basically in the level of abstraction. LangGraph, for example, is on the abstraction level of graphs. So in order to build an actual agent, you need to have at least a node and an edge. So it is a little bit lower level. We thought at Google that the perfect abstraction for an agent development kit is actually the agent. So the most atomic single unit that you can go down to is an agent. And building an agent, I mean, obviously I'm biased because I work at Google, but building an agent with Google ADK is super easy. So I, highly
they're all
recommend.
I guess they're all kind of programming languages supported, or what is the primary language you use to create such an agent? Python?
Yeah,
Probably.
so I personally use Python, but I do know that we either have plans to also open up the SDK for other languages like Java and TypeScript. Either we have done that already or we have plans to do that.
Let's once again round that off a little bit. I mean, we talked about possibilities for agent-to-agent type of communication. We went a little bit beyond with that shift of UI and that DoorDash example. I'm a bit curious. This sounds too good to be true, but there must be some limitations. There must be some boundaries. Is that something you can outline, or is there literally no end in sight so far?
You mean within the agent development kit?
Well, not so much focused on a product, but really the entire trend to build agents and to agentify
yes.
processes.
Yes, absolutely there is. And I guess the dream that we all have is autonomous agents, right? Or ambient agents, what they're sometimes called as well, where I don't even have to proactively kick off the agent, but it is an agent just ambient in the background waiting. When I get an email, it automatically triggers and does something for me. Or, the typical example, book me a whole vacation to Paris, including hotels and flights and everything. All of that, from what I've seen, is not really working great yet. So there's a lot of human oversight, human in the loop that is still required for these agents at the moment. But we do see the capabilities of the underlying large language models, AI models, become stronger and stronger. So I feel like, from my point of view, there is nothing stopping these agents to become autonomous eventually, maybe in a year or two. But right now, the limitations really are you cannot run, especially if you want to expose the functionality to your end customers. You can't have that run autonomously without a human in the loop. That's something that's not working at the moment as much as we would like to.
Okay.
Just out of interest, actually, does the Google ADK make it also easier to create an A2A agent, basically, an A2A capable agent? Is that also
yes?
The ADK?
Yeah, basically we just have a flag in there that you can set, and suddenly it becomes A2A compatible.
Yeah, I mean, sorry, just coming back a little bit to A2A, right? So what I see a little bit, the hurdle, in my opinion, is that you first need to be really familiar with MCP and create your MCP servers and tools and stuff like that, and then you eventually have the need to orchestrate this as an agent-to-agent communication, right? At some point. So that's why I'm wondering. I'm really trying to think about. Are we talking days, weeks, or months, or years until this vision actually will come true? But I guess we'll see in the future. Yeah.
Organizations will they will have to crawl and walk before they start running. So I think it'll take a few more months, maybe even a year, until we see some really cool agent-to-agent implementations from organizations.
Which is a good opportunity to go into our final question. We typically try and end on a forward-looking note. we're here to discuss innovation, but we're not done with that. We're always curious what's next.
Gibberlink.
That for sure, that we can take as a given, I suppose. But still, on a more or less funny note, what is it really that you as an industry expert see happening? Like, how do the next 6 or 12 months look like? What can we expect from this entire technology to get to?
Yeah, I think I outlined it already a little bit in my previous answers, but what I would expect happening now is companies that have started building agents with tools. They will now start building multi-agent systems, usually from what I see right now within one framework, within one team. So, for example, if you build all your agents with LangGraph or with ADK, then there might not be a need for agent-to-agent protocol yet, because you just build a more complex application with multiple agents, but still within the same team, within the same framework. From that on, I think we will see this example that we saw, or I spoke about earlier, where one department within a company builds an agent and another department says something like, that is really cool. It would be great if we could consume that agent without having actually to know how it works. That's suddenly where then A2A becomes more interesting. And eventually, I do see a future where not only within one company, agents will talk to each other, but agents from different companies will talk to each other. I had a very interesting use case or brainstorming with a customer who is in insurance tech, and I don't know about anything about insurance, but there is a broker and an underwriter in an insurance scenario that are usually from two different companies. And they were thinking already about, like, what if the broker had an agent and the underwriter from the other company had an agent, and these two agents can prepare the contract at least to like 70%, take out the most tedious manual tasks by collaborating and cooperating with each other, and the humans just do like the final 20 or 30%.
Yeah, that's
awesome.
Very interesting.
Sounds like there's a lot less work for everybody.
I would say there's going to be more interesting and different work for everybody.
Yeah. And in that scenario, it would also be interesting, right? So which company has the smarter agents who's then basically maybe able to negotiate better or something like that? But I mean, that's future thing.
In that particular case, we may have another episode on that once it happened. Once lawyers have agents talking to each other, we will want to interview you once again, Heiko.
I would love to be on again. Yes.
With that, I'd say thank you for being on the show, and thank you for sharing your insight.
Yeah, thank you very much. Thanks for having me.
Yeah, and talk soon. Yeah,
talk soon.
Bye, everybody. See you.
Thanks. Bye.